Good morning, ladies and gentlemen. Today we are doing lesson 9.1, which are nth root expressions. And what are nth root expressions? We're talking about radicals. And so if you remember a radical 9, for instance, if we're looking at radical 9, there's something called an index. Let me just mark this as blue, actually. There's something called an index that goes into this little crook in the radical sign. So when we look at this, we call this, this is the square root of 9. So the index that's implied there is 2. So just make sure that you understand that that is implied any square root, and that this is called an index. And of course, 9, we factored into 3 times 3. So 3 times 3, what happens here is basically you have under the radical 3 times 3, and one of these guys gets to escape, they go out of jail. And so you end up with an escaped convict here, and that's the 3, that's your root, okay? And so then we could do the square root of 16. Again, the implication is we've got an index of 2. That means you'll have, again, 2 numbers that we can factor out, hopefully. And so in the case of 16, 16 is 4 times 4. So there's 2 of these. You always have to have 2 when you're talking about square roots. So 1 gets to come out, the other one is shot, bong, and so you're left with a root of 4. Okay? That's basically what's going on there. Now, you should know, though, you can have radicals with something else in the index. You can have a cube root, which means you would have to factor into 3. That your number under the radical would have to be factored into 3 roots. Or you could have the 4th root. Or you could have the 5th root. 3 factors would have to come out here. 4 of a kind would have to come out here. 5 of a kind would have to come out here. But you would only get 1 escaping in each case. Each case, that would be the root. So a 3rd root, a 4th root, a 5th root. Okay? All right. So, looking at this first problem, we notice that we have nothing in the little crook here, so that means we have an implied index of 2. Again, remember that and make sure that if you aren't sure, you put it in. Okay? All right. So this number over here under the radical sign, we call that the radicand. This sign is called the radical sign. And this is the radicand. Radical. The whole thing is actually called the radical under the radical sign. And this is the radical sign itself. Okay, so if we want to get these out of this square root jail, what we're first going to do, of course, is we're going to put in the white of the 3. It's already outside, so we'll just leave that as it is for now. And then under the radical sign, 20, what can we divide 20 into? Well, we know we can divide it into 10 times 2, right? So that's 10 times 2. And so we know that we can set this up so that we've got the square root of, and then 10 times 2 is, 10 is 2 times 5, so that's 5 times 2 times 2. And it's all multiplied together. And then we have x to the 5, so that means 5x's times 1x times 2x times 3x times 4x times 5x. And then we have y to the 4th, so that means we have to multiply, let's see, times 1y times 2y times 3y times 4y. Okay. So now every pair of 2 come out. So let's just look at this. We have 2 2's here. The 5 is by itself, so it's going to have to stay under the radical sign in jail. The 2 2's, one gets shot going out, but the other one escapes. So we would write this. We have a pair of 2's, and so that's going to come out as 1 2 coming out. And then, we have the y cubed, so let's put the y cubed in here. Y cubed times 2. And so this is what came out. And then we have, let's see, a pair of x's and another pair of x's. And then we have one that's left over. So again, we'll have one that's going to get shot in the first pair, one gets shot in the second pair. And so we have an x that comes out and another x that comes out. So times x times x. So y times 2 times x times x. And then we have a pair of y's. Oh, and we have a leftover x, of course. We have a pair of y's here and another pair of y's here. One gets shot, the other one escapes. So we have a y escaping from each pair. Y here, escaping. Okay? So what does that leave us with? Okay, so under the radical, we're going to have radical. We have a 5. We have an x. And that's it. 5x. Okay? So now that's under the radical. So let's clean this up. So that means we have, let's see here. We have a y cubed here, and we have another pair of y's here. Let's do the x's though. Okay. And we have a 2, we said. So let's put the 2 first. Get the number first. And the x's, we have a pair of x's. So that's x times x, or x squared. So times x squared. And then we have, let's see here. We have y to the 3, and we have a pair of y's. So 3 and 2 more y's is y to the 5. And then what we're left with is the square root of 5x. Okay? So this is your fully simplified answer. 2x squared y to the 5 times the square root of 5x. Okay? All right, let's look at the second one. So the second one, we have an x and then we have a y squared. And then again, this is going to be the square root of 45 x to the 5th, y to the 5th. All right. So again, let's write our xy squared first. And then, let's see, 9 times 5 is 45. So we're going to put 9 times 5 here. And we know that 9 is 3 times 3. So we could write this as, let's see, the square root of 3 times 3, right? Times 5. And then we have 5 x's, so that's times 1x times 2x times x times 4x times 5x. Extend this out here, and wow, we got 5 y's. So let's do that in red. So times 1y times 2 y's times 3 y's times 4 y's times 5 y's, right? So, all right. So every 2 can come out, and 1 gets shot. So the first one, we have a pair of 3's. 1 gets shot, 1 escapes, comes out. And we're going to put that 3 here. And then we have the x and the y squared. So let's put that down, x and then y squared and that's times the 3. And then we have the 5 is left over. It stays in jail. And then I've got a pair of x's here and a pair of x's, and then this one stays in jail. And then of course one of these gets shot in each group. So I have an x that goes out here, and then I have another x that comes out here, and then I've got another x that's left, and then I have a pair of y's here. One gets shot, the other one escapes. So here's a y. And then I have another pair of y's here. One gets shot, the other one escapes. So I have another y. And then I have another y that's left in the radical. So I'm left with a radical. I've got a 5 times an x and a y. Right? So let's clean this up. So I'm left with x to the 1. So x, oh, there's a 3, so I'm going to put the 3 in front. And then I have y squared here, and then I have 2 more y's. But let's look at the x's first. We have an x here, and then we have 2 more x's here. So that's x to the 3. Okay, so we've got to make sure we get all our x's together. So we've got a 3, we've got an x, there's 3 x's. Then we have y squared here, and we have 2 more y's, so that's y to the 4th. Let's do that in red. Let's just leave it the way it is. Y to the 4th, since we're down at the end of this. And then we have the square root of xy. Okay? And that is our answer. Okay? All right. So now this radical, you'll notice, has an index of 3. Okay? So when you get an index of 3, that means you've got 3 groups of 3 inside, and 1 gets out of each of the 3. So we've got to figure out what 216 is. Let's factor that. What does it factor into? I don't know. Let's try the calculator. Obviously, it's divisible by 2, so let's try that. 216, let's turn it on. Divided by 2, we get a remainder of 108. So we know that that's divide it by 2 again. Let's see what we get. We get 54, and 6 times 9 is 54. So we have 2, let's do a little factor tree here. We have 2 times 108, which is 2 times 54, and this is 6 times 9, so that's 2 times 3 times 9, which is 3 times 3. Okay? So what do we get out of that? We've got 1, 2, 3 2's. So let's just do it this way. Let's write this over here. We have 8x cubed, which we'll leave outside, and then times the cubed root of, and under this radical sign, we have 1, 2, 3 2's, no more 2's. So I've got 2 times 2 times 2. And then I have 1, 2, 3 3's. Okay. So 3 3's times 3 times 3 times times 3. Okay, so that takes all the 216, and then I've got 3 x's, so times x times x times x, and then I got these 8 y's. That's a lot of y's. Let's just leave that as y to the 8th right now. Y to the 8th, okay? All right, so what is y to the 8th? Well, let's see. We could do it this way. So y to the 8th, we could take the 8 and we could divide it by 3. What are we left with? Let's see. That leaves us with 2 and a remainder of 2, isn't it? Because 2 times 3 is 6 and a remainder of 2. 2 remainder 2. So the remainder 2 stays in, and we got 3/8 that would go out. So let's rewrite this. So I've got 8x cubed, and then I have a group of 3 2's, and so 2 are going to get shot, 1 escapes. So I'm going to put a 2 out here. And then I have 3 3's. 2 get shot, 1 escapes. Let's do it this way. And let's use a different color for the 3. Times 3, okay. And then I have 3 x's. Okay, and 2 get shot and 1 escapes. So 1's going to escape over here. And so I've got, what do we say, an x, right? Because 2 got shot. All right, and so then we said y to the 8th, we have 2 that escape. So that's y to the 2, right? All right, and then the remainder is 2. Now what are we left with? 216, everything went out. X to the 3, everything went out. And so we're just left with the cube root of y, and the remainder was 2, so y squared. Okay, so let's clean it up. So I have an 8 here, and I have a 2 and 3, that's 6, so 6 times 8 is 48, so I'm left 48, and then I have x cubed, and I have another x, so that's x to the 4th, right, times x to the 4th, and then I have a y squared. Y squared. And then I have the cube root of y squared. And that, ladies and gentlemen, is our answer for this. Okay? All right. Another cube root problem over here. Let's see what we got. We have cube root of 81, and 81 we know can be, that's 9 times 1, 9, right? And so then let's just write this as equals, and we're going to use the cubed root. So this is going to be the cube root, and so the cube root, that's 4 3s. So 3 times 3 times 3 times 3, because 9 times 9 is 3 times 3 and 3 times 3. So that's the 81. And then we have x to the 6th. Now, you know, we could just do, we could just take x to the 6th, and we could take the 6 and we could divide it by 3, what is that going to leave us with? 6 divided by 3 is x squared. So what we could do is just, we know that out of this group, first group here, we're going to get 2 are going to get shot, and we're going to get 1 left. So we're going to have a 3 down here, right, outside of the radical sign. And then x to the 6 divided by 3, that leaves us with x squared outside of the radical sign. Now, y to the 6 over here, so this is just being, you know, we can take that 6 and we can divide 6 by 3, and we end up again with 2. So that means then we have y squared. Okay? So all I'm doing here is, you know, trying to find a way to shortcut it. I've got all these 6's, just a lot to write, x to the 6 and y to the 6. So, you know, with exponents, you can do this. You can just simply divide the power that's under the radical sign by the index, 3. So 6 divided by 3 is 2. 6 divided by 3 is 2. So you get 3x squared, y squared. And are we left with anything? Yeah, we had a radical 3 left under here. So we have the cube root of 3. That's this radical 3 we got right here. Okay? All right, and this is our answer. Pretty simple. Okay. And so one more to go. I should say one more slide to go. So now we're doing fourth root 81. So that means we're taking out 4. And we already know that 81 is 9 times 9, which is going to break down into, you know, prime factors of 3 times 3 times 3 times 3. So we're going to rewrite this as the fourth root of 81x to the 32nd. We'll have 3 times 3 times 3 times 3. And then we got this x to the 32nd. Wow. X to the 32nd. Well, all right, if it's fourth root, let's put the root sign in here. It goes inside the radical. So fourth root of 32nd. So that's really 32 divided by 4. What does that leave us with? Well, that's 8. It divides evenly 8 times. So that means we've got 8 groups of 4. Okay. So we here have all these go out, right? Every single one of them. One gets shot, right? So boom, boom, boom. We're left with 3 outside. And then I've got x to the, and then we said 8. Now what happens to the radical? Well, really it's still there, but we're left with just a 1 in here, because if we took everything out, there's always a 1 times all this stuff that's implied. So we really have a fourth root of 1 left. So this is our answer. And you've got to make sure you put this in here, because if you don't, you're ignoring the fact that there's always a 1 included, you know, 1 times 3 times 3 times 3 times x to the 32nd. It's always implied in math. So this is the correct answer. Don't forget that you've got this radical fourth root of 1. And the other thing, don't forget, whenever you have a radical, you must put the index in. If you do not put the index in, the answer is wrong. So in this case, it's the fourth. Now, the 2 is implied. That's the only one that you can, you know, square roots, you can leave it out. But all the rest of them, third root, fourth root, fifth root, and so on, put the index in. Okay. So this is, there's no index, so we assume that it's square root of 16. So there's only x to the 16 in here. We can just divide 16 by 2, and we end up with x to the 8th. See how simple that was? So, you know, if you know, you don't have any real numbers to factor, and you're just dealing with powers, you can just easily cut to the chase, divide the power by the index, and you got your root. All right, so this one's a cube root, and we're going to have to factor 125. Well, we know that's 25 times 5, and then 25 is 5 times 5. So we can redo this one as, this is again the cubed root of 5 times 5 times 5, right? And then we have x to the 18th. And I'm not going to bother to write out all those x's because I can divide the power by the index. But here we got 3 5, so one of them comes out. So 2 are shot. Bonk, bonk. One comes out, and you get your 5. And then x, this is 18 divided by 3. So 18 divided by 3 is 6. So you're left with 5x to the 6th. Okay. Now, up here I told you leave the radical in the answer. But I just realized something. You know, this is, what's the root of the fourth root of 1? Remember, this is really 1 times 1 times 1 times 1. It's 1. So we could actually take the 1 out. So we can rewrite this as 3 times x to the 8th. So we can get rid of the radical. That was my mistake. So this is actually the correct answer up here. We don't want to consider this one as your final answer. It's an intermediary step. Okay. All right. Now this one here, though, 5x to the 6th, perfectly acceptable answer. All right. 10th root of x to the 37th. Well, we can divide 37 by 10, right? What are we going to get? Well, we know that there's 3 times 10 is 30, so we've got 3, and then we've got a remainder of 7, right? So we have a remainder of 7. We would just simply take the 3 x's out. So this would be x to the 3, right? And under the radical, we're left with the remainder, x to the 7th. And we're done. That's it, ladies and gentlemen. We are done. Have a wonderful day. Take care. Bye-bye now.